Welcome to the Blueprint Room. I am your chief architect for today's explainer, and we are stepping onto the absolute most critical construction site of your academic career. Today, we are looking at Cambridge AS and A-Level Accounting 9706, specifically focusing on Cost Volume Profit Analysis, or CVP. Now, CVP is literally the foundational blueprint a business uses to understand exactly how their costs and volumes impact their ultimate bottom line. In this workshop, we are acting as elite structural engineers to break down the distinct advantages and the absolutely critical limitations of this model. The goal? To teach you how to construct unshakable top-tier exam answers. Let me introduce you to the crew on our site today. We've got Builder 1, let's call him Alex. Now, Alex works hard, but he's constantly stacking up way too many heavy bricks. He throws down raw, isolated accounting facts without ever checking if his steel frame can actually support the weight of his argument. Then we have Builder 2, Sam. Sam wants to immediately put up these beautiful shiny glass panels and fancy decorative features. Sam uses incredibly complex vocabulary but completely forgets to cement the foundational columns first by actually addressing the core command words in the exam prompt. Throughout this build, we are going to learn from their mistakes. We're going to learn how to lay down an unshakable thesis foundation, erect load-bearing analytical arguments, and construct structural sentence connections that will survive the most rigorous examiner stress testing. Grab your hard hats, let's get to work. Okay, let's dive straight into this. Mastering cost volume profit analysis is essential for Cambridge accounting success because this topic appears in literally every single examination series. This is not optional. This is your foundational bedrock. You absolutely cannot build a high-rise without a solid concrete base, and in the world of accounting, understanding how costs behave when production volume shifts is exactly that base. It is an absolute, non-negotiable requirement for your exam survival. Think about it. If you don't fully grasp how changing sales volumes impact overall profitability, your entire examination structure just falls apart under pressure. The examiner wants to see that you understand the mechanics of the break-even point, the margin of safety, and the contribution margin. If that foundation is cracked, everything you build on top of it is going to collapse.
Here is our structural grid for today's explainer. First, blueprint foundations. Second, the procedural framework. Third, examiner stress tests. And finally, we will top it all off with the final evaluation. We are moving from raw conceptual foundations all the way up to surviving the examiner's rigorous stress tests.
Section 1, Blueprint Foundations. Let's head down to the ground floor of our build.
Before we pour a single drop of concrete, we absolutely need to establish our core principles, based on Cambridge Assessment's rigorous building regulations. And this brilliantly illustrates exactly what the principal examiner reports are demanding. On the left, we have isolated facts. This is Alex's weak structure. Just stating something like CVP calculates the break-even point is exactly like stacking heavy, unsupported bricks. The true strength of your blueprint, the strong structure on the right, comes from cross-topic connections. Let me pull up a complex, high-tariff past paper question on our digital drafting screen right now. Consider this the foundational challenge. I'm isolating the building regulations right here. These are the exact assessment objectives enforced by Cambridge. Now watch as the grid flashes on these command stress points. If a question asks you to evaluate, but you just describe what CVP is, you are building a descriptive structure instead of an evaluative one, and what happens? That building collapses instantly under the massive weight of the mark scheme criteria. CVP analysis rests on precise definitions, yes, but it has severe limitations in the real world. A classic example is the assumption that fixed costs remain entirely constant. In reality, if a business expands its production drastically to meet a huge new order, they might suddenly need to rent an entirely new warehouse. That triggers what we call a step cost. If you rely on a basic CVP model without recognizing that rent might just jump up massively, your profit projections are fundamentally flawed. That's a structural connection. You aren't just stating a fact, you are connecting the theory to a real-world limitation.
To guarantee total structural integrity, successful candidates build their answers securely across these three distinct, load-bearing columns: knowledge and understanding, analysis, and evaluation. You want to avoid superficial breadth and instead aim for deep analytical stability. Let's actually apply this directly to cost volume profit analysis. Column 1, knowledge, is identifying the core rule that CVP assumes entirely linear revenue and cost functions. You know the definition. Column 2, analysis, is the heavy lifting. This is actually calculating the margin of safety or demonstrating mathematically how a shift in the sales mix alters the overall profit. It's taking the data and working with it. But column 3, evaluation, this is the highest tier. Evaluation is assessing whether the simplified theoretical CVP model is actually reliable for a specific manufacturing firm that is currently facing wildly volatile raw material prices.
If material costs are fluctuating every single week, that linear cost assumption is completely broken. You must deeply anchor your understanding in these actual accounting realities rather than just trying to memorize vocabulary words like Sam does.
Section 2. The procedural framework. Now we move to the second phase of our blueprint, where we erect the structural ironwork.
This procedural framework you see here is the mandatory construction timeline for any top-band CVP response. You always start by identifying elements from the stimulus data. Next, you apply the principles. This second step is actually where CVP shows its greatest advantage as a tool. It allows management to run incredibly powerful what-if scenarios. Want to know the exact impact of launching a massive new product line? Or perhaps dropping a selling price by 10% to capture market share? You apply the CVP principles right here. Then, you execute the analysis, verify your results to make sure they are reasonable, and present them clearly. Right now, over on the drafting board, I'm watching our two builders, Alex and Sam, try to construct a model response paragraph based on these steps. It's a classic ironwork peer debate. Alex is literally trying to fill the entire paragraph with a massive, heavy cement block of terminology definitions. Alex says, if we just write down every single formula for contribution margin and break even, we get all the marks. But Sam shakes his head. Sam argues, no way. Without a hollow space in our structure for a dynamic counterargument, this building has absolutely zero flexibility. If we don't evaluate the limitations of these formulas, we are never going to hit those top-band scores. They go back and forth, challenging each other's blueprint framing. Finally, they start rewriting their paragraph skeleton live, right there on the board, securing the definitions but immediately pairing them with an evaluative counterpoint to ensure it complies perfectly with the rigorous examiner guidelines. That is how you execute analysis.
During this execution phase, we rely heavily on what we call structural rebar, method marks. This is the hidden steel that holds your score together, even if your final concrete calculation cracks. And listen, here is the absolute critical limitation of the CVP math itself. The model only works within what we call a relevant range of activity. Imagine you are doing the math and you calculate a break-even point that requires producing exactly 10,000 units. But wait, you check the stimulus data and the factory's maximum physical capacity is only 8,000 units. The mathematical concrete just cracked. The model completely breaks down outside of that relevant range because the company literally cannot produce enough to break even without buying a whole new factory. But here's the secret. By laying down clear working, showing your step-by-step formulas, and explicitly stating your assumptions, you earn method marks. You are proving to the examiner that you fully understand the procedural framework, even if the strict, rigid limitations of the CVP formula lead to a skewed final figure. The rebar holds your grade up.
So, the crucial point is this massive examiner alert right here. Students lose marks by not showing working. Even if your final answer is wrong, method marks can save you. This is a glaring, flashing red light on our construction site. Please, no matter how confident you are, do not try to do complex contribution margin calculations in your head. You need to show your notation clearly on your blueprint. If you are calculating the break-even point in units, I want you to clearly write fixed costs divided by contribution per unit before you plug in a single number. This simple, seemingly obvious act is your ultimate insurance policy. It protects you against the mathematical limitations inherent in high-pressure exam calculations. It shows the chief examiner that you are a methodical, precise structural engineer, not just someone guessing at numbers.
Section 3. Examiner stress tests. Let's shift to the site inspection phase.
Site inspection. Before we secure this high-scoring paragraph framework, make sure your construction line is reinforced. Subscribe to Ace the Exams at Ace the Exams right now and turn on all notifications to receive our weekly structural grade upgrades. Whether you are building an IGCSE foundation or setting up an A-level skyscraper, this is your primary grid. Okay, let's look directly at the building code violations cited over and over by Cambridge Principal Examiner reports. These are the top 3 structural failures, and erecting shiny vocabulary panels without cementing these 3 specific context columns will result in instant structural collapse. Number 1 is vague details. Examiners absolutely despise generic lists. If you just write down, CVP makes assumptions, you instantly fail the stress test. You must provide specific evidence. CVP assumes volume is the only factor affecting costs, entirely ignoring macroeconomic factors like inflation or bulk discount purchasing. Number 2 is poor format and presentation. And number 3, the absolute deadliest violation is lacking specific context. If the exam question is explicitly about a local independent bakery facing rapidly rising flour costs, and your answer talks about generic manufacturing overheads without ever mentioning the bakery or the flour, your argument falls over. Right now, our builders Alex and Sam just hit an unexpected structural roadblock mid-paragraph. Their evidence beam completely failed to latch onto their main thesis column because they lost context. So I'm stepping in with a structural blueprint template, the Peel methodology. point evidence evaluation link. I show them exactly how to rivet that specific bakery data directly to their evaluation. We rewrite the text out loud, line by line, perfectly integrating the context to create a flawlessly engineered, load-bearing response block.
So this brings up a really crucial question. How exactly do top candidates survive these intense examiner stress tests? How do elite engineering students avoid the collapse that catches out so many otherwise well-prepared candidates? It's all about anticipation. It is about engineering a response that actively spots and addresses the flaws in the CVP model before the examiner even applies the grading pressure. Let's pivot and look at how we apply those finishing evaluative touches.
Section 4, the final evaluation. This is where the highest assessment tariffs are awarded.
Now, what's really interesting about this slide is how it defines evaluative thinking. It means questioning assumptions, considering completely different perspectives, and rigorously justifying your decisions with solid evidence. Top-scoring candidates don't just calculate, they structurally question and logically justify absolutely every single beam they place. I want to do a live site safety audit with you right now. An interactive viewer rebar stress test. Think of this as the blueprint matrix. Imagine a highly complex source data chart pops up on your screen. You've got a 60-second visual countdown timer ticking down. You have to extract the single most high-yielding core metric needed for construction. What do you look for? You look for the assumptions. In the context of CVP, the model boldly assumes that all costs can be neatly, perfectly categorized into strictly fixed and strictly variable buckets. But the elite student looks at that matrix and writes a paragraph heavily questioning that assumption. They point out the very real existence of semi-variable costs, like an industrial machinery lease with a fixed base monthly rental, plus a variable maintenance charge based on the hours of usage. These semi-variable costs completely distort the break-even analysis at different levels of activity. To get the top grade, you must evaluate whether relying on this heavily simplified model is actually going to lead management to make a dangerously incorrect pricing decision in the real world.
Let's detail this comprehensive methodology as your ultimate quality assurance safety check. Deconstruct, solve, evaluate. Imagine you are staring at a massive 20-mark case study for a regional transport company that is aggressively planning to expand its delivery routes. The basic foundational CVP model might just suggest that profits are going to rise perfectly linearly with the increased delivery volume. But you don't just accept that. First, you deconstruct the problem. Second, you break it into manageable steps. Third, you solve the math based on the given data. But then, step 4, you check for reasonableness. This is where you evaluate and realize the theoretical model is deeply flawed in this specific scenario because it completely ignores step costs. Expanding those delivery routes drastically means the company has to buy a whole new fleet of expensive trucks and rent a brand new logistics depot. Suddenly, the entire CVP assumption of constant fixed costs just totally failed. Finally, step 5, you justify your final recommendations to the board of directors, advising them that the initial CVP profit projection is dangerously optimistic and requires a much deeper risk analysis.
And that brings us to the end of today's site work. I want to leave you with this final critical thought. When you lay down your next CVP foundation, are you just going to blindly stack raw numbers, hoping to pass the inspection? Or will you be like a master architect, logically engineering an unshakable, fully evaluated argument? The next time an exam question features a business blindly assuming their profits will just rise linearly with their sales volume, will you be the expert who instantly spots the hidden structural limitations, like those step costs and semi-variable expenses, long before the foundation cracks? Take this architectural framework, lock the core advantages and strict limitations of CVP analysis into your mind, and apply this exact blueprint to your very next past paper practice session. Don't just answer the question. Build something magnificent. Build something unbreakable. Keep focused, keep constructing, and I will see you on the next site.